In this session, we are going to talk about doubly linked list. So what we saw till now, that there was a list in which we had one node and there was a next which was pointing to the next node. So there was just one link between the two nodes. Hence, this was known as singly linked list. Now, what happens in case of doubly linked list is that this is a doubly linked list, as you can see. Here you can see there are two links in between the two nodes. So let's try to understand what are these two links. So what happens in case of doubly linked list is that there is this node which has two fields. One field is next, another field is prev. So next points to the next node that is there in the list, and prev points to the previous node that is there in the list. So every node will be having reference to the next node and the previous node. So in this case, this is the first node. So there is no node before this particular node. There is no prev node. So in this case, prev will be null and next will be pointing to this particular node. Let's say I call this node 1. Now, okay, let's say this is node 0. So the next of node 0 is pointing to node 1 and the prev of node 1 will be pointing to node 0. So this is prev and this is next. So I'm repeating, the next of node 0 will be pointing to node 1 and the prev of node 1 will be pointing to node 0. So both the nodes have reference of each other. Similarly here, if you see this is node 2, then node 2 prev is having reference to node 1 and next of node 1 is pointing to node 2. Similarly here we'll have a next which will be pointing to node 3 and the prev of node 3 will be pointing to node 2. And since this is the last node, we don't have any further nodes, the next of node 3 will be pointing to null. So as you can see, there is two links, double link between every node. Hence, this is known as doubly linked list. So just like we created class for node in singly linked list, similarly we'll create a class for node in doubly linked list. Now let's see what will be the constructors and variables in this node. So as you can see, we have data. So in this case, 4 is the data. Then we have next, which is of type node, because obviously next will be pointing to another node. So it has to be of type node. So we have next. So in this case, this is the next, which is pointing to node 1. And then we have prev. Again, prev will be of type node because this is again pointing to some another node. So we have these three variables, data, next and prev, and then we have a constructor. We are making a constructor where we are taking data as the parameter and we are using this constructor. Every time you will see, we will create a new node object. So using this constructor, we pass data and then we initialize the data for this particular object as data, and then next and prev, by default we will keep it as null. So whenever we do something like node equal new node, let's say 8. So we are trying to create a new node using this particular statement. So what happens in this case is that a new node is created in memory, the data of which is 8, the next of this particular node is null, and the prev of this particular node is also null. So it is created somewhere in the memory. So if we have to insert this particular node somewhere in the list, we will see how to do that. So next we are going to talk about how to insert node in a doubly linked list. Let's see that. So now we have seen what is doubly linked list and we have also seen what is singly linked list. Now the question is, what are the advantages or disadvantages of the one over the other? So first let's talk about the advantages. So in case of doubly linked list, if someone gives you reference to this particular node or this particular object, so using reference to this particular object, you can move in both the directions. So in this direction also and in this direction also. So number one advantage of doubly linked list is that you can move in both the directions, which obviously makes it easy to access elements. So in case of in case of singly linked list, if someone gives you reference to this particular object or this particular node, you can just move in this particular direction. You can't move in this particular direction. So you can't access elements after this. So you will always have to go to head, and for access the elements, you'll have to traverse through it. This is the advantage of doubly linked list over singly linked list. Now talking about the disadvantage, the very first disadvantage, it is we are storing extra object variable here. So we are storing an extra variable. So obviously this is going to take extra space. And every time we are doing the insertion and deletion, we will have to manipulate one extra pointer. So if you see, it's easier in terms of operations to insert an element in a singly linked list comparison to doubly linked list, because there we just have to bother about the next, but here we won't only bother about next, we will also have to bother about the prep. So we will see how to do the insertion and deletion in doubly linked list. Let's start with the insertion. Now let's talk about inserting a node in doubly linked list. So I've written in short DLL. So let's say we have a doubly linked list here. So let's say this is somewhere in the memory. When we are writing a program, we obviously need reference to this particular DLL. So how do we get a reference to a particular DLL? So just like in case of singly linked list, here also we have a head which is pointing to the first node of the DLL. So head will again be of type node. So we will have node head. So this is an object variable which is going to point to type, or which is going to point object of type node. So this head always points to the first element of the linked list. Okay. So now what are the different possibilities for inserting a node in this particular list? The number one possibility is we insert a node at the beginning, even before the head. So let's say this is the head. So we will have to insert a node even before the first node of the list, or even before the head. Or I'll have to insert node between any two nodes in the list. So it could be here, it could be here, it could be here. So let's say it's here. So I have to, let's say, insert a node here in between the nodes in the linked list, or I have to insert at the end. So right now it's pointing to null. Let's say I have to insert a node here. So these are the different places where we'll have to insert the node. So let's see one by one that how do we insert the nodes at different places. So obviously for inserting the node, we'll have to create method. We already have a class node. We need a class doubly linked list. We'll name that class doubly linked list, in which we will be maintaining this head, and then also we will be writing the required methods. So we will write down a class doubly linked list. So initially, let's say the list is empty. So if your list is empty, head will have value as null. Okay, and in this we will have different methods. Let's say insert middle, insert beginning, or insert end. So now let's see one by one how to insert a node at the end, at the middle, or better to say in between the two nodes. Not exactly the middle we are talking about any two nodes. Okay, and insert at beginning.